Welcome to FX mechanical classes. So today our topic will be again the same, that is viscosity numericals. Today our topic will be numericals. I've already posted easy and medium level numericals, so today is a chance for advanced level numericals. So its difficulty level will be a little high, but if you understand, it's not that bit also. So today we will do the 3-star questions and it will definitely enhance your skills. Okay, so today our topic will be numerical based only. So let us start with the 3-star question. I am writing this question. So I will not mention again, it's a 3-star question and the question is as follows. So let us proceed on the question now. I will just write out the question here. A circular disc of radius r is kept at a small height above a fixed beam Okay, this is the question. So these are the given terms. This radius r. Actually here you just need to focus on the concept since no value is given. So you need not to worry about the quantities. This r is given at a small height above by means of layer of viscosity mu. This is mu. The disk is rotated at the angular velocity omega. Then obtain an expression for viscous torque. This is unknown. Okay, so as you can see in this question, this is moving with the angular velocity omega. this is r, it's of radius r, and viscosity mu is given, where this it's been a means oil. Here it is viscosity mu. This is oil actually. Different one replacing color. This is oil. This is mu. This blue one. And here it is omega, angular velocity omega, it is rotating. And for that we need to find out the torque on the disk. So first of all we need to see one thing, that many of the students get confused that we have to integrate, where to integrate and where not to integrate. See, I will tell you one concept, that here what does the torque means? Force into radius, that's it. So torque at specific points will say this point, then we will say I am talking about this point. So here we will here we can find out torque by force into radius. Here also we can find out. These are all the specific points. But here it is finding out of the whole disk. It means we have to find torque by considering the concept of integration only. We will consider a small strip and then we will find out the torque. Okay. So let's start it. This is stationary. This is stationary. It is basically a bed. It is saying that it is basically a bed of which it is lined. So first of all, to find the expression of torque, we need to focus on two things. We will write what is given in the question. We have the velocity omega. Okay. So we know that tau is equal to mu du by dy. Okay, and here du by dy. Here we are first considering about the velocity. So first we will write v is equal to r omega, no doubt in this. And why I have taken this? It is moving with constant velocity. Okay, so we can write this as velocity only. So we have find out the velocity r omega, and this radius it is. And we have the radius also. Radius is given. So we can write this as, we will write this as, wait. Let me small it. V is equal to r omega, where I have this gap h. I have drawn this gap h. It's not visible, so that this pink to red one is gap h. Okay, and so it is tau mu we are given with mu and v upon h. Here the y is basically the h, which is representing by the pink circle. Okay, so we don't have the velocity, we are not finding, so but we can write it in terms of angular velocity. So what we will write this as, mu into omega r upon h. I guess till here the concept, there is no doubt in this concept. Now what we have to do is, we have to find the viscous torque. So for this torque we will do, before I talk about torque, I will, since I said that we have to do integration, so we will just magnify and I will show you that what actually the thing is. So I magnified it, this. Let's consider, this is r, this full radius I have considered r. Let's consider this radius, this one. Wait. Use a scale, otherwise it won't look good. Let's consider this. This is basically dr. Okay, this is dr. So after magnifying this, what we will do is, this is dr. So we have considered this as an elementary step of this whole r. Now we will just draw that what it is actually, what will actually we will do. Let's consider this. Wait, it's just a little bit approximation. Oh man, it's so dark. Okay, so let's focus on this part. I will show you what I have done is, this is the elementary step that I have shown is dr. So, and this is the h. This is the h. Okay. And you will say that why it is, that why this triangle is made. See, this triangle is made because due to shear force that is exerted due to the imagine a circular disc rotating, so there is a shear force exerted in this liquid one. This is the liquid, I have told you this is the liquid, that is oil. This is oil actually, here oil is there. So due to the since the disc is rotating above oil, so shear force will definitely will exerted. Okay, so we have considered this as an elementary step dh. dr we have considered already. So now let's proceed on to calculations. What we will do is, for calculations part, we know that tau, wait, tau is equal to mu v by h. We have already calculated, and here mu by h into omega r. Fine. Now for the, it is basically the shear stress. Tf is shear stress. Now for the torque, we will do is, torque is equal to what? This is our question. So for that, we will do one thing. dt, because I told you that since it's a small step, so we have to consider dt. We will do integration to find out the complete torque. This we can write as dt is equal to mu upon h into omega r into Oh yeah, where it has gone? Where it has gone? Oh man. I don't know where it has gone. Back. Sorry for the disturbance. There's due to this bug. I know what hell I don't know. Whiteboard. Yeah, here is the question we are talking about. I don't know, there was some bug, it has gone away. I am really sorry for that. So here we were. Pi r dr dot r. Okay, now first question comes to my mind that how it is. See, what is shear force is equal to pressure into area, and torque is equal to F into R. Just remember this basic concept. Okay, so basically for the torque we can write it as elementary concept I am using, P into A into R. Okay, and you know that we have calculated the shear stress. So for shear stress what we will do is, and now I will explain how it came. This was the shear stress. This is the shear stress. Sorry. Yeah, this is the shear stress. So we will write the exactly same formula, mu upon omega r, and mu upon h omega r we have just put into here. Okay, and for the torque what we have done is we have just multiplied this by 2 pi r dr. Now your questions comes that how it is 2 pi r dr. It is nothing but 2 pi r dr into r. See, this is the radius. Okay, and 2 pi r dr. See the surface area this is covering. See the surface area. If you see, wait, I will explain you like small, right? Let me make small. See, this whole disk you can see this one. I'm referring to this one. I'm referring to this one. How it is 2 pi r dr, I will tell you. This 2 pi r dr is due to the reason that when it will rotate with the angular velocity omega, it will form something like this circle. You agree or not? Because it is moving, and this plate will this is the cross sectional view. If we see the top view, this disk will follow like this rotation. Okay, and for this is actually, you know that this is 2 pi r, isn't it? But here we are considering r as a small strip, isn't it? So what we have done is this 2 pi r, now I will explain it. It's nothing but area, that is mu upon h. This is we have done. Then this 2 pi r dr. 2 pi r dr means this is 2 pi r. I think so in mechanics also you have covered this concept, that 2 pi, how this 2 pi r dr concept came. See, assume this is a circle, and this is r, and this is, let's say this is dr. It's just millimeter. So this area is 2 pi r, means the circumference, and if we will multiply the circumference into dr, so it will give you the area, isn't it? That's why it is 2 pi r dr. the circumference of a circle is 2 pi r. Fine, no doubt in that. And since we are considering an elementary strip, so that is dr, small. So this is our circumference. This is the circumference is 2 pi r length into thickness will give you the area. So no doubt in this. So that's why this is the area actually. This part is for area. This comes for the force. Okay, force into area into radius. Sorry, this is the pressure. So I am really sorry for this. This is the pressure. Oh, of course it is pressure. I am really sorry for this. This is pressure. This is area, and this is radius. Okay. So our half work is done. And why we have multiplied this force into radius? Because we are more interested in this one, the upper limit, the radius one. So we have to just now integrate it. We have got the expression. Now for the total torque, now I will just review. For the total torque, this is T. Total torque is integration of, this was the dt, I will just do the integration of mu upon h omega r 2 pi r dr. Wait, I'll make it more clear. Sorry, dt we have find out that dt was mu upon h omega r 2 pi r dr into r. Now we will just simplify and then it will become mu omega upon h 2 pi r cube dr. Fine, it is dt. Now for the total torque T, the total torque is 0 to r dt. That is, we will just integrate it between the limits 0 to r omega two pi r cubed dr. And what we are interested, we are basically interested for the radius here. It is 0 and it is r. So this is the upper limit. Okay. So that's why I have put the limits as from 0 to r. We have integrated it, and finally after integration, this is the constant, this part is the constant, this is the constant, so it will as it is come out, only the r will change. So the constant part will be mu omega upon h dot 2 pi integration of 0 to r r cube dr, and our final answer would be mu omega upon h 2 pi r 4 upon 4, limits will be r to 0, and so here is our final answer. That is, after simplifying you will get this as T is equal to 1 by 2 pi mu omega, sorry I will write it more clear, wait, T, this the answer is T is equal to 1 by 2 pi mu omega upon h r raised to power 4. Okay, I hope so that this was the tough question which I have got. Now we will proceed on to another 3-star question, and I will like to give you 1 3-star as a homework also, that you may do for your skills enhancement. And that one question I will definitely discuss in next class, but I will see to it. Wait, Let's do one example, and a 3-star question is, the question is as follows. Axial cylinders 10 centimeter and 9.75 centimeter in diameter and 2.5 centimeter high have both ends This is the question, and here the unknown terms are, and the given quantities are this is the first cylinder D1 diameter, and this is the second cylinder. This is D1, this is D2. Two cylinders diameters are given, and this is given. Two cylinder diameter is given, and its length is also given. Both have same length, and the ends are open, and a viscous liquid is filled between them. Okay, a torque of 1.2 Nm means a torque is generated when the inner cylinder on the inner cylinder, when outer cylinder rotates at 90 rpm. Okay, find the coefficient of viscosity of liquid. So the thing where you have to focus is there. This is the given term. This part you have to focus and read it very carefully. A torque of 1.2 Newton meter is produced on the inner cylinder. Means the torque basically is produced by outer cylinder, and it is acting on inner cylinder, and this is rotating with 90 rpm. So we have to find the coefficient of viscosity of liquid, and see here figure is also given, so it will give you a better idea. Let me draw the figure also. The figure is as follows. I'm just doing the cross section view. Okay, so I will just start with here first. The cross section view is as follows. This is two cylinders, and let me do the cross section view. These are two cylinders. So this is my mistake, I'm sorry. I'm sorry to take a lot of time on this figure, but it will give a better visualization and understanding. So I have to give it some time to this figure also. Okay, fine. And since the cross section, we have to get this also. Okay, this is the diagram. Now I will explain you the what's the given in the question. This is 10 centimeter. Okay, so this portion is wait, it will not scale only, otherwise it will not clear it. This portion is and we are concerned about this portion. And we are also concerned about this one portion. Wait. This portion. Okay, now it's over. This is this portion, the blue line that you are seeing. This is 10 centimeter. Why 10 centimeter is the outer coaxial. Coaxial means the thing which is coaxial means what the coaxial term means that it is on the same axis. Okay, so consider this as an axis. Okay, I will explain you in detail. Say this is the axis. The blue line, assume this blue line as an axis, and if I assume, and not assume, it is actually from the center you can see that they are on the same axis, means they are parallel to each other. So these are two coaxial cylinders, and the outer cylinder is 10 centimeter in diameter. Okay, this is the cross section against the outer cylinder, the purple one, which is the, I represent this as a blue color, that is 10 centimeter and 9.75 centimeter. Okay, so it is 10 centimeter and this is 9.75 centimeter as clearly stated in this question. Wait, I will just explain you that also. 9.75 centimeter. So see, this is a cylinder. This is cylinder 1. Let's say the red one is also a cylinder and green one is a cylinder, and the red cylinder has a diameter of 10 centimeter and 9.75 centimeter. And one more thing you have to observe, that this one is, now we can easily find the difference. What is the difference actually? The difference is, if we calculate the theory, this is the actually the H. This is the actually desired H. What we are concerned about. This is the H. Okay, so this is the H. Now you have to do that clearance. So I will just find out the clearance. What is H is? H here is 10 minus 9.75 upon 2, which stands out to be 0.125 centimeter, as everything is given in centimeter. So I will just convert into meter and it will be 0.00125 meter. Fine. Now velocity gradient we need to find out. So velocity gradient is nothing but du by, I will just increase. Velocity gradient is nothing but du by dr, and here it is constant, so we can also write this as this is velocity. So velocity upon h. R here is h. Okay, that is this one. You can see this. We are mostly concerned about this only. So this portion basically is the clearance, and this is a question is this is also given. This is 2.5 centimeter. Here R is H or R. This is represented by both the things. So R, here we got the V. Now we need to find out the shear stress. This tau is equal to mu du by dr. Okay, so it will be 377 mu. Wait, for the tau we have to calculate, like first we need to calculate what is Fs, because we need to find out Fs first, and for that we need to find out the shear stress, that is tau. For tau, what we will do is we will just Fs, the shear stress, is equal to tau tau is equivalent to pressure. Okay. So Fs, we can find out that shear force, it is the shear force Fs can be written as, here let's calculate the first value of torque, that is mu u. What is u here? U here is 90. Okay, so 90 rpm. So first of all, let's convert the 90 rpm. 90 rpm in radians. So what it will be? The direct formula is, I've told you how to derive the formula, but the direct formula is, the radians is pi dn upon 60. So here pi, diameter is 10. See here, we are concerned about this outer one. Diameter is 10 into number of rpms is 90. See, torque is exerted here. We are talking here. So we have taken 10, not 9.75. This is the maximum distance, that is r. R is, if we take the maximum distance, it comes out to be 10. So we will not take 9.75 into 90 rpm upon 60. Let's calculate this out, and it comes out to be 0.4712 meter per second. Okay, now we'll proceed further. Clearance, I have already found out that h was equal to 10 minus 9.75 by 2, which comes out to be 0.00125 meter. So now du by dr, that is v upon h, here the h is the clearance, that is r, so it is 0.4712 divided by 0.00125. This is 0.00125. This comes out to be 377. So after this, we will just proceed further. Now we have to find out the shear force, because we are just interested in torque. So for that, force is must required. So we have found out the torque, and now force. For shear force or Fs, that will be tau into area. I guess there is no doubt in this at all. And for this 377 mu, we have already got this value. Where is 377 mu? Because this is 377, no doubt, but wait, this is 377, and when we are considered tau is equal to mu du by dr. So this is 377. So tau is equal to 377 mu. Okay. Now we can write this as tau is equal to 377 mu. Now the main concept comes. What will the area? Okay. So the area would be, I have told you the same concept. Here it will just rotate about, and I told you that we are taking consideration of 10 because the torque will act from this to this point, the maximum point. So we are all considering this as the R. So what we will do is, we will just do that. This is 10 centimeters, so our answer will be 5 centimeters. So we can write this as 0.1 upon 2 is equal to R. Okay. So this would be 377 mu into area. Area, what we have to do is, wait, this area is 2 pi R. This you have learned in previous question. Now it is just the circumference, isn't it? That is 2 pi r we have calculated. This 2 pi r is calculated. And you remember we have done the dr also. This dr. So basically what is dr? This thickness, isn't it? So this thickness, it was there in thickness, and here we are concerned about the area it is covered. So you just imagine that this is the cylinder. So this, if this is cross sectional, this is the cross sectional, and if it will rotate, so it will just form a cylinder. Like you assume the cross sectional view of a cylinder. Okay, so this we have calculated this portion, the circumference. See, this is the cylinder, and whose cross section we have calculated. This is the cross sectional. So we have calculated the radius. We have calculated this one. This one we have calculated 2 pi r. Now we have to just multiply it by height, isn't it? Height means what? Length. Sorry, length. And length is given as 2.5 centimeter, isn't it? See here, it is 2.5 centimeter. It's basically cylinder. So we have just calculated 2 pi r, this, and then length. So it is just pi r l. 2 pi rl or pi dl. So this is 2 pi r into length, which is given in this length. We will consider this length. Okay, this is the length. So we will multiply 2.5 centimeter. So 2.5, if we will convert, it is 2.5 upon 100, because we are taking an SI unit. So this comes out to be 2.961 mu. Okay, now torque. Now this we have calculated. This is the Fs. Now let us proceed to torque. Torque is nothing but Fs into R. Okay, so here it is. Torque is 2.961 mu, which we have already calculated, into R. R is 0.1, I said, 10 centimeter, 0.1, and 0.1 was the diameter. So here it is the radius. Let's divide by 2, that is radius, 0.1 meter, and it will become tau is equal to 0.14805 mu. And see, torque we know. See, you know this torque, isn't it? So we don't have to do anything. We have to just equate 1.2 is equal to 0.14805 mu, and you will get mu in SI quantity. That is, mu is equal to, this is the final answer, (1.2) divided by 0.14805, and after calculating it would be, let me calculate, you can check it out. Let me calculate it out. With the calculation, it will be what is that again? 1.2 divided by 0.14805. It comes out to be, yeah, it comes out to be 8.106 Pascal seconds. Okay, means Newton per meter square seconds. 8.106 Newton per meter square seconds. This was the second question of a tough exercise. Okay, now I will just just that I will show you the detail of the shear force and shear strain. So wait, I will show you one thing. I will give you a challenge question that you have to do, and I will discuss that definitely in next class. So just wait, I will just show you the challenge question. Okay, I'm not getting it. I will just write this question only. Otherwise, it will just take a lot of time. So, no issues. I will write this question. I will show you the table on next class. That non-Newtonian one. So the question, the challenge question is as follows. I will discuss in the next class. Question is, it's also 3-star question. A solid cone of radius r0 and vertical angle 2 theta is to rotate at an angular velocity omega. An oil of viscosity mu and thickness h fills the gap between the cone and housing determine torque T. Wait, like this. Determine torque T required to rotate the cone as shown in figure. Okay, this is the question. Wait, I will just shorten it. Wait, I will select it off. This is the question. You can note it down the question. This is the question. Shorten it. It's not coming in. Some issues, I guess. Wait. This is the question. Okay, just note it down. I will now let you know the figure also. So don't worry about the figure. Just note this down the question. And wait, I will just give you time. Let me draw the figure first. don't go by the figure because I am taking any random angle, so you have to, it's just a theta general. This figure is only for the representation purpose, not for the actual calculation. is basically filled. Actually, this one is here the liquid is filled. Okay, here the liquid is filled. This blue portion which you're seeing, it is the liquid is filled here, and this liquid is nothing but it is oil. This blue color that you're seeing, it is oil, and this is H, means the distance between this is basically H. Wait, sorry for using long notation. I will not like this one. It is H. This is the H actually. This difference, and this is the R naught. This is the R naught. And this oh yeah, this is omega. Okay, so this the figure is in front of you. This is the figure actually. Well, this is the H. Don't forget, I will just magnify it and tell you that this is the distance between this red line and this is H actually. Okay, so I guess the figure is clear. I will just now, I don't think so it will come in one page. So sorry, if just note down the figure. Just note down this figure first. This is the figure, and this is the question. Again, the question too big. I don't know why the screen is just getting some disturbance. This is the question. So basically what is given, that radius 20, radius is R naught. Just focus on this. Angle is 2 theta. This is theta. And rotate at an angular velocity omega, which is already given in the shown. Viscosity is mu, thickness is h, fills the gap between the horizon, determine the torque. This is to be determined and rotate as shown in the figure. So it is only determined in terms of the quantity that is given. Okay, so this is the basically question, and you have to determine the T, torque. Torque is to be determined. I will explain this figure. This is rotating with omega. This is the R naught, that is the distance from the highest limit to the means the central line. This is the R naught. This is the fluid inside, that is oil, and it is the thickness, that is H, which is also known as R, and then you have to just calculate. It's not that tough. If you will do it, is easy. And next class we will proceed on to further numericals. And last thing I would want to tell you, that many students have the complaint of that we have done the we have done all about Newtonian fluids and non-Newtonian fluid we have classified, and what about a non-Newtonian fluid? Why we are not talking about non-Newtonian fluids? Okay, I will just give you an idea of that if the case comes of non-Newtonian fluids also, as I told you, the value is experimental, so it's not that tough. What you have to do is, suppose I will just give you an example. It's just an example, just consider it as an example, and it's also 3-star. It's a question only, but I will just give an example, and it's very easy. Suppose this A parameter is given, where shear rate is, that is del u by del y is 0, tau is equal to 0, and it is 0.5, 1, 1, 2, a bit off. Clear the board first. 1 2 1.5 3 and 2 4. Second example B where shear rate del u by del y is equal to 0, tau is equal to 1 and values are 0.5 1 3 1.5 2 and 2 3 4 5. This is the B liquid, and let's grab it off. I don't know why it is not clearing the canvas today. The third example is where it is given that del u by del y is equal to 0 and tau is equal to 0, and the values are 0.5 1 1.5 2. It's creating a lot of disturbance. I don't know why. 2, and this is 2 3 4 5. This is the liquid C. This is D1 is liquid D is del u by del y is equal to 0, tau is equal to 0. Here it is 0.5 1 1.5 2. Here the values are 0.35 1 1.84 2.83, and the last one E1 is del u by del y is equal to 0, tau is equal to 0. Then you have to do is 0.5 1 1.5. Get rid of this problem. I don't know what happened. 0.5 1 1.5 2. Here it is 0 0 0 0. Okay, so now you have to tell us that which of this is which liquid. So for the analysis we can see that I have told you in previous class also this is 0 0. Okay, so from this we can classify it that it is either Newtonian fluid or Birringham's plastic, isn't it? I have taught you that further also, that for the Birringham's plastic and Newtonian's fluid the slope is linear, but since it is 0 0, the intercept is 0, so it's definitely Newtonian fluid. It's Newtonian fluid. Now let's proceed on the second one, this red one. Here we can see that everything is same, means you can see that the quantities are increasing, like 1 2 3 4 5. It is increasing. Okay, and as you can see that this is the point. Here intercept is not 0. You can see that it is 0.5. So but it is also increasing at a linear scale, so it is as easy. It is Birringham's plastic, isn't it? Now we have to see of C. Now you have to focus on this C. Till now you have got this concept, but now you have to focus on this end part. You remember I told you a formula, tau is equal to m du by dy raised to the power n. And then I have taught you that in Newtonian fluid also, non-Newtonian fluid also, that it goes like this. For the Newtonian fluid, suppose this is the Newtonian fluid, this is the Newtonian fluid, this is the Newtonian fluid, then the graph goes something like this. So you have to classify it that it goes where. So for this you have to just see that what is the type of behavior it is showing. So for C you can see that the shear stress is C0 1 1.52. As it is increasing, the C is also increasing. Okay, so you can see that with the increase in shear rate, the shear rate is also classified as a non-Newtonian. So it's clear that it's non-Newtonian. and since it is increasing with a decrease in shear rate, you can see this, that C1 I will get, I think so it becomes pseudoplastic. Wait, I will just explain you that why it is pseudoplastic. See here, the focus on the shear stress, this C. Wait, this is the B1 I guess. Where's the C? Wait. That's why I was confused. The values I have written was different. Sorry, this value is something different. Wait, let me change the values. The values are 0.59, 1.0, 1.36 and 1.7. So here you can see that as the shear stress, that is the velocity gradient, is increasing, it is also increasing. But here you can see that it is not increasing, it is not following any linear pattern of that. It is following as a function. So since the fluid C, the shear, if we see that the shear stress decreases with the increase in shear force, so this can be classified as pseudoplastic. Why is this disturbance creating? I don't know. Pseudoplastic. Whereas D, if we talk about D1, this is D is 0.5, 1.5, 2, 3, 1.84 and 2.83. Here we can see that the shear stress is increasing in increase in shear rate. So it is known as dilatant. And fluid E is ideal liquid because it has no effect on anything. So it is also known as ideal liquid. Now, I am sure that most of the students have confused, and they should confuse, that here I have said that it is, here I have used for fluid C and for fluid D, I have used that for decreasing, here shear stress is decreasing and increasing shear rate. Now you have to identify this statement. I have said shear stress, I use the two words, shear stress and shear rate. So don't get confused. Shear rate is the thing with respect to time. It is the change actually, not the see here there is this change of 0.5, here 0.5, so it's constant, and here the change is 0.41, then 0.36, then 1.7 minus, you can calculate this. I will get the exact value. 1.7 minus 1.36, it will give you 0.34. So as you can see that it is decreasing, its rate is decreasing. This rate is decreasing. That's why it is pseudoplastic. Because here we are considering our n, and n is considered with rate. Okay, and D. Let's talk about D. Here in D, what happens? Here there is difference of 0.5, and here for C there is 0.5 difference. Difference is 0.35. Then there is a difference of 0.65. Then there is a difference of 0.84, and then there is a difference of 0.99. So can you see that if the shear stress remains constant, that is the shear rate remains constant, and the shear stress rate increases more than the shear rate. So this is classified as dilatant. This is the dilatant one. And this dilatant one, I have shown you in previous lectures also that what this dilatant is actually. See, and now I will show you that how it is dilatant. You need not remember that also. It's very easy. That what is increasing. You have to just remember this graph. In short, I will explain now. Wait. I'll just clear the concept so that you don't have to learn that also, that we will forget about that dilatant and Birringham's plastic, how it is increasing. See, just focus on this graph part. Just go mathematically, you will never get confused. This is Birringham's plastic, this is Newtonian fluid, is no doubt, and this is pseudoplastic, and this is dilatant. So I have said that the shear rate shear rate and shear stress. You can see that there are two graphs like this and this. Why it is not working? This is one and this is another one. So you know that it is the increasing slope. If you will calculate the slope, this is the increasing slope. Tan theta is constantly increasing, this theta is constantly increasing, and here the theta is constantly decreasing. If you draw a tangent, and then you will just find out here the theta is constantly decreasing. So decreasing means, what is decreasing means pseudoplastic. I have told you the graph, that's why I have asked you to the non-Newtonians how to identify. So I guess I have done with it, and advanced lecture on this is completed. I hope so that you have got the advanced concepts too. So thank you, have a nice day ahead, and if you like, you may subscribe also. Thank you.